Thank you for joining us. My name is Jonathan. I'm the VP Marketing of ARMO. In today's webinar, we're going to talk about the exciting topic of protecting your CI/CD pipeline from development to production. There is no doubt that protecting your code along the entire CI/CD pipeline is the only way to achieve absolute Kubernetes security. It can be performed right before production or much earlier in the development phase. In today's webinar, we have Shimon, the CEO and co-founder in Datree, and Shauli Rozen, the CEO and co-founder of ARMO. Both will discuss the different aspects of protecting your CI/CD pipeline from the development into the production. So without further ado, let's start. Shimon, take it from here.
Hi, everyone. Thank you so much for joining. How are you, Shauli?
Great. How are you?
I'm doing great, doing great. So, when we thought about making this webinar, we said, first of all, we want to make an interactive webinar. We don't want it to be boring. And second of all, we said it can be an interesting, connection because we have the Datree project, which is very popular in GitHub, has 5,000 stars, and it's more about, running in the CI/CD and checking for misconfigurations. And you have ARMO and KubeSec, which runs on more on the cluster side, and also has thousands of GitHub stars, which is very, very popular. And I thought, it can be a nice joint venture to see how you can do it on the CI/CD and then also on the CD level towards production.
Yeah, definitely.
Cool. So maybe I'll talk a little bit about I'll introduce myself, talk a little bit about the challenges in terms of misconfigurations in Kubernetes and how you can integrate within the CI/CD flow. And then you can take it for deeper into the cluster.
Definitely. Let's do that.
Cool. Okay. So can you see my screen? I'm trying to present now. Do you see a big ship? Cool. Okay.
Yes, we can, Shimon. We can see it.
Amazing. So as we said, protecting your entire CI/CD pipeline from development to production. So a little bit about myself. Actually, there is a misconfiguration here. I turned 33. So now my API version is 33. I'm the CEO and co-founder of Datree. I'm an AWS community hero. My background is in DevOps, infrastructure, CI/CD, development. My previous role, I was an engineering manager for a company called ironSource. It is publicly traded on the NASDAQ. And it was very interesting scaling a company from 30 to 1,000 employees and 400 engineers. And this is where I tackled a lot of the issues that we're solving today. So a little bit about Datree. So in Datree, we help prevent misconfigurations in Kubernetes environments. And the way we do it is we integrate within the development workflow, and we sit before the production phase. And I'll explain a little bit more in later slides, but basically it's a CLI, open source, written in Go, and it gives you the ability to run checks against Kubernetes configuration files and Helm charts and see whether they're running according to your organizational standards and policy that you can define. It can be things like make sure that you have a memory limit, CPU limit, liveness probe, readiness probe, and basically any custom rule you can do. You can write anything you like. You can say, I want all my workloads to be named Shauli, and it can happen. So as you understand, policies is how we roll, and we've seen hundreds of organizations, and we've seen a lot of postmortems with companies that unfortunately had, outages due to misconfigurations. And this is what we're here to talk about today. So let's take a day in the life of a beautiful company, Unicorn Rentals. Everything is nice. The sun is shining. We're using Kubernetes. We're using Helm. We're scaling up. We have 10 developers, 20 developers, 30 developers. And, they're running workloads on Kubernetes until, one day the rainbow turns into a fire. and someone makes a misconfiguration and it reaches production, and then we're all, tackled with this issue of like, okay, so things happen, we make mistakes, but how can we make sure that those mistakes do not happen again? And which types of mistakes am I talking about? Mistakes that happen to small and large companies, mistakes that happen in different verticals, to companies like Google and Spotify and Airbnb and you name it. Here are some examples. Like Zalando was down because they're missing the correct YAML structure. So they put in the cron tab definition in the wrong place in the YAML, which spawned like 5,000 pods for them and bombarded their Kubernetes. Blue Metador had an issue where they got an external container and they ran it on their cluster. Little did they know that this container had the memory leak and it consumed the entire cluster's memory. And because they did not have any memory limit or requests, it, got them into having an outage. Or, for example, making sure that you have a concurrency policy that is correct to your workload, or not routing traffic to star, because if you route traffic to a star in an ingress definition, it will just route all the traffic from the cluster to this ingress. So though this is just the tip of the iceberg of simple examples of misconfigurations that can happen. But obviously it is very hard to, to remember all those misconfigurations and how to make sure that they do not happen again. So in order to do this, I propose a centralized approach. So obviously don't trust the default configuration, define policies for your organization, and delegate the knowledge for your developers to make the right thing. And remember that it can happen to anyone. So how can we prevent this from happening in the future? So number one, define policies. And what I'm talking about is a centralized policy that will run on all code changes in all of your developers' laptops and or in your CI/CD processes. So define the policy. For example, you have solutions like Datree that come in with predefined policies out of the box, or you can use solutions like Open Policy Agent, OPA, which is completely open source, but then you need to write all of your policies by yourself. The second thing, once you define a policy, you need to make sure that it is granular. So you might have a company-wide policy to make sure that you have a memory limit of maybe 4 GB per workload. But then maybe I'm running an AI workload and, and I need 40 GB of RAM. So I need to make sure that you have a granular way of configuring policies. And the second thing that I recommend we do is integrate policies inside the organization. Because believe me, when I was in Iron Source and this developer made a mistake, I sent an email to everyone and like, listen, here's a mistake that was made. This was the problem. This is the solution. This is how you avoid it. And we all know what happened with it. Nothing. Because when you send emails to developers to do stuff, it's not going to happen. And I'm a developer myself. How can you remember all of those standards when you're writing code? And there's so many, it is like impossible. So I believe that everything has to be enforced during the CI/CD process. And if a developer makes a mistake, they should see and understand and be able to fix it before it reaches production. And the third thing that I believe in is that you need to have control and a way to review and monitor what is going on. Because maybe you put in a policy, but how do you know? Is it being adopted well? Do you have the ability to dynamically adjust the policy? Because, setting up the policy is one problem, but then maybe we have a policy running on 100 Git repositories, but now I want to make a change. How am I supposed to, open 100 pull requests in order to change a policy? I need some sort of, centralized policy management in order to be able to propagate a centralized policy to all of my repositories and to all of my developers. And secondly, I need to have a way to monitor all the changes and all the invocations that happen in order to see what is going on. So one way to do it is using an open source solution like Datree. But, again, I'm talking about the practices. You can go and build your own, with Conftest and Gatekeeper and OPA. It is just, the question of buy versus build and whether you want to build it or not. So a little bit about how it works. We provide a CLI solution that is for policy enforcement. You can specify policies from the dashboard. We have 30 policies built in. 21 of them are enabled by default. And then you can enable, disable them. You can write your own, and you have a single place to manage it. As I said, it is an open source CLI, and it is very, very easy to install and use. You can use it in your development, in your VS Code, for example, or simply in your terminal or in your Jenkins, GitHub Actions, or whatever. So let me show you, we're all technical people here. So, let me show you what we all love, which is the terminal. The black terminal. Shauli, am I showing the terminal? Did I get it right?
Yeah, you are.
So in order to use it, it is very simple. So here we have our website. As you can see, it is for developers. And if you go to our quick start, you get directly into our docs. In order to install the solution, it's just a one-liner, a curl to install it, and you don't need to do anything. You don't even need to sign in. You can do it as an anonymous user. So you curl this, you paste it in your terminal, and then you get the Datree CLI, which I'll show you here. This is our GitHub repository. It is very popular. Actually, I'll refresh this because we now have a new logo here, as you can see. And we encourage you to submit changes and talk to us, and we're very, very open with the community. So let's see how it works. So if I look at, we provide a Kubernetes manifest file that has a lot of issues in it. This is the one, KS demo, and I can run a Datree test against this file up. And what will happen, you will see the tree run in action. So number one, we provide a YAML validation. So first of all, you need to make sure that you actually have a valid YAML. Seems simple, but people make those mistakes. Number two, we provide a Kubernetes schema validation. So when you run the Datree test, you can specify different versions of your target cluster. So let's say you have Kubernetes 1.22, and you want to make sure that you're not using deprecated API versions. So you configure it. You can set one globally for all of your runs, and you can override it using the CLI. And the second thing is to actually run the different policy checks. So ensure that your image has a pinned down version, ensure that you have a memory limit, liveness probe, and so on. I won't go into all the policies. If you sign into our dashboard, where is it? Up. You will be able to see that you can define all the different policies. You can enable and disable them. You can even read all the policies. You can change the texting. And you can look at the centralized invocation policy. So this is just a very broad TLDR of what I believe is the right way to, go and monitor your policies, embed them during the process, and prevent problems before they reach production. So this is from my end. So Shauli, what happens now? Let's say I'm great, I'm using Datree, but as much as I want to, Datree will not solve all the world's problems, There are more problems.
Yeah, Datree solves most of the world's problems. Specifically, global warming is something which is very critical to all of us who do not deny it. But then anyway, yes, once you are going through the CI/CD, I think one of the kind of like inflection points that I personally consider is, before you have a cluster and after you have a cluster. Once a cluster is running and is operating, it can be the dev cluster and then the production cluster. There are two things that happen. First of all, many things can still happen, of course, in that phase. But also, when you do those tests on those clusters, sometimes you have much more context and you see much more of what's going on. And I think that's what I would like to focus on in the second part of this webinar. So we started, very far at the left, and we're now moving right into, clusters. And let's talk about what happens there. So let me share my screen. Okay.
I can see your screen, your lovely GitHub, and now
yep,
lovely PowerPoint.
And now the presentation. And yes, we are all about Kubernetes security built for developers. And I'm also, just a little bit about myself, if my screen will work. Yeah. Okay, so this is me. This is where I am when I'm very when I make sure to take very good pictures of myself. So I'm Shauli. I'm a CEO and co-founder of ARMO, and I'm a software developer turned entrepreneur. I don't develop as much code as I used to, but I'm very, into the details, and I find myself looking at that console that Shimon showed you, and I will show you as well quite a bit. And I was, whenever I write this slide, I'm thinking like what my life looks like, and it's basically 5 a.m. wake up, go surfing, can't complain about that. 8 a.m. build Kubernetes security products, and 9 p.m. put 3 boys to sleep. You see 2 of them here on the bottom, and 9 p.m. maybe, I start at 9 p.m. It probably ends at like 11 p.m. and repeat. So that's kind of like me and what I do, and this is what we do in ARMO. And when we think about Kubernetes security, there are 4 key elements to think about, and this webinar is about CI/CD to production. And this is not me, this is not my slide, it's my slide, but it's not my content. This is taken from the Kubernetes documentation. There are the 4 C's of Kubernetes security, which is the cloud provider you run on, the cluster that you are running, the container within the cluster, and the code within the container. And the reason I'm putting it out here is that each one of those layers should be looked in from CI/CD to production. So, there is the cloud configuration that you need to make sure are okay in your CI/CD and in your production cluster. There are many things, and Shimon showed many of them, that on your cluster before you actually run it, as you run infrastructure as code. The containers are definitely there before there is cluster, and they are early in the CI/CD, and of course the code itself. So this is just for you to keep in mind that those 4 elements are things that you need to always cover, but don't think of them in isolation. Think of them throughout the continuum of the CI/CD. That's kind of like the way I look at it. And as I mentioned, just a few minutes ago to Shimon, I see when you think about CI/CD production to production security, I see like a major inflection point from the point that there is no cluster. So everything is code and configurations, and that's where you kind of like focus mainly on minimizing the attack surface. You scan your code, you scan your container, you scan your configuration, and you basically do environment hardening. And that's the stage where you are in a continuous effort, which is mandatory as a first line of defense. You basically check all the boxes, and there are many boxes, as Shimon said, that you need to check to make sure that you're actually, minimizing the risk. And then a cluster appears, and a cluster runs, and pods and applications and the resources are created and manipulated. And you want to make sure that, first of all, no malicious changes are created to those configurations that you actually made sure that are okay when you went live. And also you want to protect against those threats that you don't know of. Because basically you covered many of the areas, but you might have missed something. And that's where the next line of defense comes into play, because you close as many holes in the fence as you can, but eventually, and we're going to talk about it later, you want to be protected against the unknown. And that's a very, very big part of security. And then just one last thing in that sense is that you want to create a reinforcing cycle between those two parts. And I'll give you an example. One of the things that we really like to check before a cluster is live is, for example, what kind of roles and access privileges I have in my cluster. And I can check them and I can see if I have privileged roles, for example. But should I have privileged roles? Maybe a user should have that privileged role that I see that he has. What you know in runtime, you know exactly what privileges users are really using. So you can actually use information from runtime in order to minimize the attack surface and actually add more strict configuration controls to your cluster and to your RBAC based on what you actually saw in runtime. And that's kind of like the reinforcing cycle between the two. And that's kind of like how I look in general on security. I look at it as there is like this posture management element that you need to take control of. You need to find all of your known vulnerabilities, misconfigurations, and this will always leave some holes in it. You need to take runtime protection and establish a deterministic runtime protection model that is not built on anomalies and behavioral analysis, that is actually working, and you need to create a reinforcing cycle between the two. And just as an example, if you think about where can cluster and security drift come from, yes, many of them can come from the CI/CD and from and creating new versions, but you need to be actually aware of out-of-band changes because that's what attackers will do. Attackers will actually try to manipulate your configuration to get privileges from themselves. So there are a lot of things you need to check there, and there are many tools that will help you do that, and we'll talk about that as well. If you think about, you have a cluster now, and you need to check it, and I want to know what's my posture, and I want to know what's my risk. And one of the things that we hear many times from our customers, actually very similar to what Shimon said about misconfigurations pre-deployment, is how do I know, or how do I understand if my cluster where do I stand? How do I know? Do I run 10 tests? Do I run 11 tests? And that's actually where I see best practices frameworks, and even regulators and companies and organizations like the NSA that many people frown upon. I think they are very, very valuable in creating benchmarks and frameworks that help you put a structure around your security posture and where you stand. The three that I'm most fond of are the mid-way attack framework, the Kubernetes hardening guidance that was issued by the NSA and CISA a couple of months ago, I think are very, very good at that, and the CIS benchmark. And there are tools, open source tools that help you do that. One of them, for example, KubePench, and you see the example output here, does that for the CIS benchmark. And there's Kubescape. This is something that we at ARMO released to the community, which basically does that based on the mid-way attack framework and the Kubernetes hardening guidance. This is what you see here, basically on the right-hand side. Just to show you how it works very quickly. Basically, if I go to GitHub, this is our GitHub page. Shimon, I might take you up on that image that you put. I want the same one exactly. No, I'm kidding, but it's really, really nice. It's really, really nice. So this is our GitHub page, the Kubescape GitHub page. The installation is very similar. This is very common today. You can just take the bin bash, and I have a cluster here that is pre-prepared just to show you, how it works on an actual cluster. So let's give GCP a little bit of time to get organized with itself. So the installation is very, very quick and easy. And then I'm going to run basically Kubescape scan framework, and I'm going to use the NSA framework.
This is so cool that they've released it, the NSA and NIST. It's really, really good.
Yeah, it's I've read so many such documents from the NSA. Some of them are very blurry. Some of them are so boring. They made really made good work with this one to make it very succinct, very practical. and I really love it. So basically, you get the output right in your in your terminal. You get all of the resources that have failed or passed, each one of the tests that are defined in the NSA. Some of those tests can be interpreted in different ways. So we put our minds into what we think is the best way to go about it. And in our documentation, you can see exactly what we do in each one of those tests. But eventually you get like the score of where you stand. And, of course, you can go to our portal to see just in a more visual way, and you can manage
and what can I do in the portal? Can you explain the added benefits in the portal as opposed to the CLI?
Yeah, of course. So basically, first of all, sometimes people like to see things, in a specific manner. So first of all, what you can see is you can see how you stand against all the different frameworks. So you have the NSA score that you got, the MITRE score, and the ARMO best practices, which is our latest framework that we have created. You can see all of your resources and exactly which resource passed which test, and you can actually start to manage. You can see which the severity of each one of those, posture chest. And for example, we can see that we have like, we have 12 workloads here that allow host pass. So if you go to that and you look at it, you can see, okay, well, actually, when I look at it, I see these are like CyberArmor systems and the Cube system. Actually, these should be okay. So I'm going to mark them as an exception and stop it. And now from now on, I'm not going to get those via alerts. So because one of the main things we want to do in the system is to continuously reduce the number of alerts. So you can get to a static state very quickly. And of course, you can see your results over time, and you can actually, do additional things like creating your own, your own framework. So if you go to our settings, let's see, if you go to our settings, you can see that in frameworks, I've created a framework which is called Shauli, which is basically just have 8 control, because sometimes for my organization, there are just some things that I want, and I can, of course, edit it, add more controls to it, or reduce the controls from it. So that's kind of like what you can do. And the idea, again, if I want to kind of like make the pinpoint, how it works, is that in my mind, what you would do is that you take this and you create a cron job within your cluster, and this wakes up every day and tests where you stand against the framework and gives you drift information as to what have changed from yesterday. So you have new deployments, new namespaces that actually segregate your posture state, and that's a very big part, in my mind, of the value, like seeing how it changes over time.
And do you recommend installing it? Like if I wanted to scan periodically, let's say nightly, should I put it in a Cicd, or can I do it through your platform automatically? How does it work?
So this is actually, to be honest, this is very, it's an open source. So if someone wanted to take it and put it within the Cicd, they can probably do that. We also have a mode where you just install a cron job within your cluster, and that cron job wakes up every night, does the scan, and this is how you kind of like check everything that you do. We're adding many things to it. So, one of the things that we're going to add in the next few weeks, for example, is an admission controller. So same thing, but now let's enforce. I want to create things that now I want to actually avoid from getting into my cluster. So those are the type of things, that's where this specific project is going towards. But as I said, this is just, a part of all you need to do. So this is the left side, the posture management part. And now you also need to add the runtime. And in my mind, that's the second level of security. You start with the early check in the Cicd, this is what you guys do. Then you add posture control to the cluster, and then you add runtime security, which is basically a way to assure that malicious code is not behaving in a malicious way in your environment. And this is basically we have a patent around being able to create a model where every microservice that goes up into your environment is automatically attached with an ARMO guard. An ARMO guard is a very lightweight in sidecar, I would call it. It's not a sidecar. It's not like it's big everything. And it basically assures that only your microservices run and that only they communicate with each other and access data. Now, of course, we can talk about it for a lot of time. And, I'm happy to go into details if everybody or anyone finds it something that they would like to explore. But in my mind, this is the way you need to go. You need to, start with your posture and then move into runtime security, because I think that's where really, all of the attacks, that's honestly, that's when they happen. Every company that has been attacked and every data that has been taken out has been taken out from companies that were sure that they have no misconfigurations and that they are sure that, their posture is great, but the posture is never great. And that's why I think a combination of the two, you don't want to be an easy target, right? That's a very big problem. You don't want to be an easy target and you need to take care of your misconfiguration. But don't think that if you did that, you're no longer a target. And that's kind of like the way I look at the security world.
Cool. Makes sense. So I guess GitHub is the best way to find the Kubescope, right?
GitHub is like, in my mind, just Google Kubescape. If we're not the first result on your search, we did something wrong. That's that's what I'm saying. And
okay.
Yeah, it's always great. It's great to have this audience and to have this opportunity.
Cool. So thank you very much, everyone. Thank you for joining. We answered some of the questions that were in the Q&A. I typed in the answers so you can see. So thank you very much, Uli. It was great.
Yeah, and I'll come to Cafe Shraga.
See you. Let's meet for coffee, definitely.
Yeah, but you can't take a salad. You need to take something more serious next time.
No problem. Thank you very much.
Great night.
Bye-bye.
Cheers. Bye-bye.